Okay, see Lindelof videos solving double absolute value equations. And what that was going to look like is we're going to have absolute value on one side equal to absolute value of something on the other side. If we can talk really quickly about this absolute value stuff. When you see these bars, please make sure you read them absolute value, and then whatever's on the inside is what the of is. So this is absolute value because of the bars of x. Anything inside the absolute value bars are actually called the argument. I don't know how important this is to your professor or to your teacher, but it's something good to know. Absolute value is the bars, and argument is the thing that's inside. All right, here we go. We're just going to do one problem. We're going to actually do it twice, though. So we do have a double absolute value. We have the absolute value of 3x minus 1 is equal to the absolute value of 2x minus 4. So what we're going to do is the same thing we always do. We're going to try to satisfy these bars right here. So we're going to drop the absolute value bars. This is our intention, is to create two equations. So our first equation, E1, is going to be 3x minus 1. And then we're going to set it equal to the argument of the second absolute value, which is 2x minus 4. So that's our first equation. The second equation looks really similar. So the second equation, E2, our second equation, is on the left-hand side, it's the same, 3x minus 1. But on the right-hand side, we're going to take the opposite of all this stuff. So we have positive 2x here, so we have negative 2x. That's the opposite, right? Here we have a negative 4, right? So the opposite of negative 4 is plus 4. And then we're going to just solve them both. So I'm going to solve them one at a time. Usually I like to gather the variables first, so I'm going to gather the variables to the left-hand side. Taking 2x from both sides gives me x minus 1 is equal to negative 4. So far so good, right? Remember, we're just trying to get this x alone. So what I'm going to do is I have a negative 1 here. I'm going to add a 1 plus 1 here. And we get x is negative 3. Right? So some people get hung up. Let me say this really quickly. Some people get hung up. This is x minus 1. But remember, this minus right here is also a negative sign. So just to be clear, in the same way that a plus sign is a positive sign. All right, so here we go. So here's our first answer. Just going to solve again. We're going to gather all of the variables to one side. So I'm going to add 2 x's to both sides. Going to get 5 x's minus 1 is equal to 4. We good? Hopefully you can see this negative 1 here. So I want to get rid of this negative 1. So this is minus 1, but it also means a negative 1. So I'm going to add positive 1 to both sides. End up with 5x is equal to 5. See, this is actually not so bad, is it? Dividing both sides by 5. This is just kind of two-step algebra where x is equal to 1. We good? So I think that all makes sense. But what I did want to do, because I think we have a minute, is so some teacher actually was talking to me about this, and she said, well, what if I do it the other way? Well, this is called reflexivity. So it's like looking in the mirror. So if it's true this way, if it's true this way, it has to be true that way. So just to prove that, so you'll know, it doesn't matter what order you do it in. So what I did was I flipped the order. So now I'm going to do this one. I'm going to take this 2x out here, two equations. Remember, all right, when you're solving absolute value equations, you're usually going to set up two equations. And the first equation is going to be 2x minus 4 is equal to 3x minus 1, just the way you see it here. Same. The second equation is where it gets different. So the second equation is exactly what you had on the left, which is 2x minus 4. You don't change that, but you take the opposite of the second argument. So this was positive, right here it is positive 3x's, so I'm going to take negative 3x's, right? And this is negative 1 to the negative 1 here, so I'm going to put a positive 1 here. I'm going to solve both equations. I guess we'll do this. We'll take negative 3x's, and I'd like to have my variables on the left. It doesn't really matter. 2x's minus 3x's is negative x, isn't it? Minus 4 is equal to negative 1, right? It's negative 1. So this gets weird for a second. You're like, dude, it didn't work, but it does. Positive 4 here, positive 4 here. Opposite x equals 3. So my buddy likes to do it this way. I don't know why. I just call this opposite. And the opposite of negative x is x, and the opposite of positive 3 is negative 3. But what he says is this. He said, think of this as a negative 1. So he divides both sides by negative 1. Negative 1 divided by negative is 1, and 1 times x is x. And 3 divided by negative 1 is negative 3. So we have this answer. And if you look back, that's what it did here, right? Negative 3. -3. So that does work. And let's try this one. I'm going to add 3x's to, I'm doing equation 2, add 3x's to both sides, add 3x's. We get 5x's minus 4 is equal to 1. That's this positive 1 right here. I just brought it straight down. I'm going to add 4 to both sides. As you can see, this is going to work out. So you never have to worry. Well, which side do you drop? Which side do you make the opposite of? It doesn't matter. It doesn't matter. So is 5. So this looks familiar, doesn't it? Divide by 5. Divide by 5. X equals 1. So we did it reflexively. That is to say, we switched order from here to here on this one to this one, and we still got the same answer. So I hope this is helpful. People get all freaked out about double absolute values, and actually they work just like solving solving most absolute value equations. So hey, thanks for watching. If you haven't already subscribed, please do. And your comments are always welcome. I like questions. It's cool. Thanks.